With the Fisher product development process, it's important to know that everything is team-based. We operate mostly on sales-driven timelines, which basically means that we don't set when our projects are done, like many other consumer product companies. The sales force says when they need a product, and then we work to get the best product to them in that timeline. In order to do that successfully, we've found here at Trek and at Fisher that prototyping is the key to our success and the key to making good, robust solutions that meet our user needs. At the start of every project, when a project is kicked off, we have to do research. We need to know who's going to be using this product, where they're going to be using it. Anyone that's been involved in the mountain biking industry knows that the way people are riding and where people are riding has changed a great deal over the last 10 years and continues to change from year to year. So to be good product developers and to develop good products, we need to be sure we're designing products for the people that are using them right now in the way that they wish to use them. Part of designing a good bicycle is to make sure it rides right. It needs to look right, it needs to feel right, but part of the success of a bicycle is how it rides, and that's driven by center lines. Center lines are basically a layout of the tubes and how the cockpit fits, the reach from the handlebars to the saddle, where the pivot suspension points are. And in order to develop a good bike like that, our ACG group makes several prototypes, mule prototypes we call them, not pretty, more breadboard prototypes to really get the feel and fit of a bike before it goes down the line in the development process. When we're making these prototypes, we're often using existing tubing, and we know we're going to be using certain shock hardware, certain cranks or gears or tires. So to make sure that we're prototyping things and everything fits together, we utilize clearance models in SOLIDWORKS to make sure that the tubes we're designing and the place that we're putting these tubes won't interfere with each other and we'll have a workable product. It really cuts down on the amount of rework we have to do on early prototypes. This is an example of an early ride prototype. Might turn the stomach of most industrial designers because it is indeed not pretty, but it really gives us what we need to know to start developing a beautiful product inside the physical envelope within which we need to work. We'll test these prototypes locally, or if, say, it's a bike that needs to be ridden down a big mountain. We often take trips out to Whistler, British Columbia, or to Colorado Rockies to test bikes in a bigger hit application. That's one of the funnest parts of the job, though, is getting out there and riding the bikes that we really enjoy. It's a good time. Once we've identified the geometry of the bike and the physical envelope that we're working in, then as an industrial designer, the project really comes onto our plate, and we need to reconcile that with what some of the other designers have called the brand form language. Each brand at Trek has a different feel, a different vibe, a slightly different customer. And in order to reach that customer, we've made brand form decisions and our brand form language boards, which we use to drive the aesthetic design of the products. Based on this brand form language, we do a bunch of sketches and a bunch of spatial exploration or a bunch of shape exploration to get the most beautiful and functional product we can find. After we've done several sketches and maybe carved some things out of foam, move on to CAD. Several of the designers at Trek, myself included, use SOLIDWORKS to do this early iteration. It's a great way for us to design in 3 dimensions and spin something around and really make sure we're staying within that physical envelope. A product like a bike frame, there's several components that get bolted onto it, and interferences are a huge issue. You can design something beautiful, but if it doesn't function and articulate exactly right, you really haven't designed anything at all. So being able to iterate in an environment where we can constantly check to make sure the fit and function is working in a virtual world, we can then proceed to a prototype with great confidence that it'll perform well. This is an example of the design direction. We've gotten the prototype from the ACG group. We've translated it through the brand form language into a robust industrial design model. This model then needs to be prototyped so we can ride it, see if there's any structural issues, and get passed on to our engineering group. You can see there the transition between what was designed in CAD and what was made in our Protoshop is almost identical. It's key to us to make sure that we can represent in CAD what we're going to have physically so we can make good decisions both in the computer and in the real world. We also get to ride these prototypes too, which isn't a bad part of the job. We do a lot of manufacturing in Waterloo, Wisconsin. We also do some manufacturing overseas. And of course, if you're making a product, you both have to design a product that works and you have to design a product you can make. So at this point, we really take a hard look at the geometry of what we're creating and how we're going to produce it. You need to be able to make it first and foremost, and 2, you have to be able to make it profitably. So we do rely a great deal on our manufacturing personnel to come in, look over our shoulder on the computer, and make sure that what we're doing isn't going to tie their hands or make things more difficult for them than it needs to be. Also, assembly. We have to be able to bolt things together. As a young designer, a mistake I made over and over again was you put something together, yes, the fasteners fit in there, but you can't get the wrench on it. Using clearance models in SolidWorks, we can make sure not only will our hardware fit onto a bike, but also the tools that we're using to assemble it together have clearances so we can actually make the bike efficiently. The ability of SolidWorks to communicate well in 3 dimensions has helped us immensely with our Asian communication. Often when English is not an option, you need to communicate with images in 3D CAD, and this has helped us a great deal, making sure we get exactly what we want and exactly what we need from our foreign vendors. So we've come from our ACG Ride prototype to an ID design model, and finally to a manufacturing resolved solution that we can actually produce in the real world. The 3 models there represent 3 different prototypes that were made, and all iterated in CAD based on the same centerline geometry and the same clearance geometry. Now we come to our final solution. It embodies all the physical characteristics that the ACG Ride prototype needed to. It's manufacturable, it's profitable, and as you can see by the different callouts, it reconciles itself with the brand form language. This is exactly what we're going for when we start a project, and we're very pleased with the result we got here.